the history of the microscope mimics the history of science itself. And by explaining how the field develops, I also introduce some of the key concepts that we will be concerned with throughout this course. This picture here shows an instrument developed by a physicist from Oxford, Robert Hooke, who may be familiar to you from Hooke's law. He was really an ingenious physicist who made many developments in science, and he was also the great nemesis of Isaac Newton, who lived in Cambridge at the time, of course. That's a story that's interesting in itself, but I won't go into this. But it's interesting how personalities clashed, also in science in a major way. So the image on the left is a rendering. This is of Hooke himself, of the instrument he built, and what you see is what is called the modern compound microscope. Microscopes to this day contain the same components as this compound microscope built by Robert Hooke, so it's worth looking into what he's done. So if you look on the image on the right, this is a modern replica of the instrument that Hooke might have built. And you see here there's a flame, and this flame acts as a light source. So on the right here there is a container of paraffin that fuels the flame, and the light from the flame is then thrown onto the sample holder, which you can't see here on this image very well. It's a pin containing the sample, and this bulb here filled with water acts as a lens, and so the light is focused through this lens and this lens down here onto the sample. You can see it better on the image on the left here. There's a little pin. The pin contains the sample, for example, a droplet of pond water containing microorganisms, and then the light from the flame is thrown onto the sample, and the light is then reflected into the microscope here, and down here you have an objective lens, a tiny lens with high refractive power, and then there's an eyepiece up here, an ocular. Today this lens would be called the tube lens, and we will refer to it as that, the tube lens. And so the image is formed on your retina. You look through here, and it is magnified by the combination of the objective lens here and the tube lens up here. And you can focus the image by bringing the objective closer or further from the sample down here, simply by turning the body of the microscope, this tube here, in using this screw thread that you see down here. So that allows you to adjust the focus and bring the object into focus. And it's called a compound microscope because it consists of both an objective lens and the tube lens in combination. And this is very much of what a modern microscope consists of today. We have better lenses and we have slightly more complex systems, but it is that simple system of objective lens and tube lens that we consider in this course. Hooke produced wonderful images with this instrument that he drew, and so some of the drawings that he made from objects that he looked at were published in a book called Micrographia, which he published in already in 1665, and this book became an instant bestseller because really it opened people's eyes to the microcosm. So at that time, people were still fascinated, as we are to this day, of course, by the skies. And so optics was really the field of astronomers. And now, in fact, using similar technologies and similar science, people could now not only look out into the skies, but could look at the world at the very small, the microscale. And this really was as fascinating, if not more fascinating, to people around at the time, because they saw things that they never realized existed in their everyday environment. So what you see on this right-hand side is a rendering of what Hooke saw when he took slices of cork and imaged them at high magnification. You see these little structures here, and he called these structures cells. So the word cell in biology now comes from this very image that you see here that was published in this book. And the reason why he gave these structures here the word cell was because they reminded him of the quarters that monks lived in, and so he had no notion of what the biological significance of the word cell, or of the concept of a cell was at that time. That came almost more than 200 years later by other scientists. But nevertheless, he was the first to coin that word. I mean, these are admittedly very big cells, but nevertheless, this is where this comes from. He produced images of insects, and he was a genius at drawing them in great detail from what he saw in his eye. So this is the image of a flea, and down in the corner on the right-hand side, you see a photograph of a flea, and you can see how amazingly accurately he was able to draw the details of this animal, which of course was impossible to be seen without the invention of the microscope. So you can see why people became fascinated and why people looked at the images that he produced in Micrographia with great fascination. In fact, slightly earlier than Hooke, this man here, Anthony van Leeuwenhoek, who was a Dutch tradesman, he traded fabrics and clothes at the time. He lived in Delft. He produced a microscope that was much simpler. This is not a compound microscope because it consists simply of an objective lens that you can see here mounted in this brass holder. And there's a pin here, and the pin contains again the sample, perhaps again the droplet of water containing the microorganisms that you look at. And what you do is you look through this instrument from behind, and you look against the sun, and so the sample is then on this pin in front of the objective lens. You look through it, and then by adjusting this screw here, you could bring the sample closer or further away from the objective lens, and make a sharp image on your eye, a magnified image on your eye. Now, in fact, although this is a simpler instrument and it is technically less sophisticated than the compound microscope, this instrument produced better images than Robert Hooke's instrument. And the reason for that is that Leeuwenhoek was able to make objective lenses, these lenses here, that were of far better quality than what Hooke was able to do. And so he made these lenses by taking small capillaries of glass, flint glass. He flicked them through a flame, and then the tip of the capillary melted, and a droplet would then just fall off, and surface tension would draw this into almost a perfect sphere. And a little bit of polishing, you've got an almost perfect small lens. And so because the radius of curvature of the lens, the smaller that radius is, the higher the refractive power, and therefore the bigger the magnification you could obtain. So he obtained with this thing magnifications of 270 times or so, which is extraordinary. And he was certainly the first person who was able, with instruments like this, to see the first living cells, the living single cell organisms at the time in pond water. And he reported this, and nobody believed him because, he called these animalcules. Nobody believed him because he because he was so ahead of his time. I have perhaps a story about this in a later slide. But you can see that, his instrument enabled major discoveries. So here's a contemporary of him, Jan Swammerdam, who was a medical doctor, and he looked at lots of different things at a time using instruments just like that. Here's a drawing of the instrument that he used, clearly similar to Leeuwenhoek's instrument. And here on the right are drawings that he made of dissected insect organs, and you can see the extraordinary detail that he obtained using such instruments. You can also see that actually at the time, to be a good microscopist meant that you had to be good at drawing what you saw, and that in fact meant that some people were not able to do this profession if they weren't able to be make good renderings of the images that they saw in their eye.